Oh, hello. Didn't see you there. I was just reading this great book about two-shot injection molding. Why don't you take a seat and I'll tell you all about it on this journey through education.
We will be covering the history, applications, manufacturing, and benefits of double injection molding.
Here's a short clip showing the process of double shot injection molding. In the upper mold, the first layer of the injection process is done, and then in a few seconds you'll see it flip around for it to do the second shot. So that red piece was the second shot that was put onto it within the one process.
In 1872, John Wesley Hyatt and his brother Isaiah patented the first plastic molding machine. They used a material called celluloid, which was an improvement of a commercial plastic invented in Britain. Their injection machine used a needle and plunger, which pumped melted plastic through a heated column into a mold. In the 1940s, when manufacturing boomed from World War II, the first screw injection molding machines were made. The 1970s saw further expansion of injection molding, including the first attempts of two-shot injection molding. Keycaps were the first known example of products made by two-shot injection molding. This method allowed for legends on the keycaps that would not fade or collect dirt, and were fully flush with the surface of the keycap.
So what is two-shot injection molding? It's actually exactly what it sounds like, and involves combining two different plastic resins in one processing step to create a molded part. The first step is the injection of the first resin into the mold, where it cools to form a solid piece. This is simply the process for single-shot injection molding. The next step is to automatically rotate or move the mold, into which a second shot of resin is injected to fill the mold. The two resins then bond together to cool to form a solid part. The part is ejected from the mold and the process continues automatically.
How does this apply to what we've learned in class already? Well, I'm glad you asked. Like most things in material science, it relates to thermodynamics. See, double-shot injection molding is required to counteract sink effects from thick walls. If you remember our discussion about the Biot number, that number must be less than 0.1 for uniform cooling throughout an object with no shrinkage. Thermally thin bodies undergo Newtonian cooling, which means that there are no thermal gradients, which means that every single point on the object will cool at the exact same rate, making sure that the final product has no deformities and is exactly as modeled. And to show what happens when you do not have a thermally thin body, please take a look at this photo of a cake. Thank you.
Injection molding. Plastics must flow into both the mold cavity and the negatives left in previously molded parts. The machines are similar to polymer extruders, but extrude into closed dies at high pressures. This process is a combination of casting and extrusion and requires specific design strategies in order to be successful.
Many reasons why you'd want to use this process as opposed to the other option, which, just a little background, the other option of a single shot injection molding would basically be the process gets its first layer in one machine, it's moved over by a robot arm, and then put through another machine to get its second layer. And there's a lot of cooling time differences with that process. But with this process, it's more cost effective because you are only dealing with one machine. And with the one machine, it's fewer employees, less waste from that machine. As well, the aesthetics of the process you make are much nicer. Picture a voltmeter with just a singular material, not made out of the color and the other rubber grip. It wouldn't be as nice and it wouldn't sell as well on shelves. Ergonomics are much different. You can use the two different materials, so anything with a rubbery grip is usually made through two-shot injection molding, and it allows that rubber grip to stick to that hard plastic, leading to the stronger bonds in between materials. And there's just less handling for assembly by having that two shots within one process instead of two. So a few things that it's used for today. Basically any product that has a grip, from a voltmeter to a toothbrush. I know this was something I saw a lot when I was on co-op at Schick, that it was always used for the razor handles. One of the problems that came up with single shot was that razor handles could almost droop, so you can see on that bottom picture how it forms an arc. That's like perfectly degreed, but maybe if you did that in a singular shot with a large amount of plastic, it wouldn't harden the correct way. So that two-shot allows that first layer to harden and then that second layer to go on.
In conclusion, dual-shot injection molding is a two-phase extrusion of two polymers into a closed die. Once injected into the die, the polymers cool and bond to form a single solid component. This process is used to manufacture everything from computer keys to mouthguards because it is an easy method of combining multiple colors of polymers as well as multiple types of polymers. Dual-shot injection molding also reduces the need for multiple manufacturing steps, reducing the cost of manufacturing many products. While this process is relatively cheap and easy, the dual-shot method needs to be used to avoid the sink effect in the final product.
Well, that was simply fascinating. Thank you for joining me and the rest of the crew and learning about two-shot injection molding today. We hope to see you next time.